This is a tale of inherited projects and why we kept Hasura. I'll introduce myself quick, mostly because I'm socially obligated to force people to look at pictures of my cats whenever possible. I'm a software developer based in Madison, Wisconsin. I've been professionally developing for about 3 years. I primarily work with back-end closure code, but I've been known to do a React or two. I have 2 cats named Spock and Tiberius. They are the most adorable kittens of all. When I'm not coding, I am typically either doing watercolors or doing generally nerdy things. I play a lot of D&D and board games. I currently work at a company called Outpace, which is a pretty unique shop in that we have a product that we consult on, but we also do some run-of-the-mill consulting. Today, what I'm going to do is talk about one of our projects, go into some of the background for that, and then talk about our migration plan from a proof of concept to a production-ready app. I'll zoom in a little bit on Hasura and GraphQL and why those things made sense to keep in our production application, and then finish off with some things we learned along the way. So a little bit about this project. We inherited this because the original developers didn't want to support it going live. The end goal of this was to have a consumer-facing web application that was globally available. Some of the things we noticed right away when we got that is there was no real source of truth for where all of this data was stored. There was Kafka and Redis, a couple of different Postgres databases. It was hard to track down how one piece of information was flowing through the system. It also included several new bits of tech that we were unfamiliar with, including Hasura, some other third-party integrations, Kafka, and we weren't sure that we were going to be able to support that going forward. What we decided to do was approach this like we were going to build it from scratch. Some considerations that went into this were we had a pretty tight timeline. We were looking at about 3 months from inherited application to going live. We also had a requirement to migrate from Heroku to AWS, which meant we were going to write a lot of YAML in a short period of time. Our team is generally back-end heavy, so we're really comfortable writing complex algorithms and doing operations work, but we have slightly less capacity for the front end. And given that this was a consumer-facing website, we had to take that into account. This also needed to be scalable because we were eventually going to launch it globally, and we were on the hook for long-term support. None of us wanted to get woken up at 3 a.m. We broke this down into what most applications are doing at the end of the day, just handling data. We needed a place to keep it. We needed to be able to search in an efficient way. We needed to be able to query for specific pieces of data. We needed to show it to the end consumer. And we needed to take it from the one service, transform it into something that our system could handle. There were some decisions we were able to make pretty quickly. One of them was Postgres. One of my coworkers often says, no one's ever gotten fired for choosing Postgres. And that feels pretty true still. We also knew we didn't have the bandwidth for hand rolling our own search solution. So we went with a third party, which was Algolia in this case. We've had a lot of luck with them so far. Their documentation and library/plugin widgets are really great. We were also comfortable keeping React, both because we didn't have the bandwidth to bring in a new framework, and it was what we had the most experience with in the past. This left us with a couple big questions. How were we going to handle translating the backend that included several microservices and Kafka and Redis and Postgres and all of that into something that we wanted to support going forward? Our main product that Outpace has a pretty large data pipeline that's all written in Clojure. So we were comfortable taking on that work of simplifying all of that into one more streamlined Clojure service. That left us with one last piece, and that was Hasura. We weren't really sure what it was doing at first, and we weren't sure if we were going to keep it. We broke this down into a couple of decisions. One was, are we keeping GraphQL, or do we want to go with something we know more, which was just rewriting it in a REST API? If we did go with GraphQL, were we going to keep Hasura or build something ourselves? With the first decision, it was more, at the end of the day, a path of least resistance than a true embrace of GraphQL. We knew REST well. We were comfortable that we would be able to support it and build it quickly. And we liked the idea of getting rid of a third-party dependence, especially since we were on the hook for supporting this long-term. However, the front-end work required to convert the existing app into something that was able to consume new REST APIs was overwhelming, especially since some of the baked-in behavior that GraphQL provides, like subscriptions, would have been hard to recreate. And it still would have been work we had to do on the back end, wiring up everything that Hasura was originally providing us. Given that, we said, okay, we're going to keep GraphQL, leaving us with a lot of questions, like, what is Hasura? We all had heard of GraphQL before, but none of us had really used it in production or in any meaningful way. So we kind of also needed to answer that question. What is GraphQL for us? Which left us with a little bit of fear around our ability to support it going forward. We took a step back. We decided to approach it from, let's start by understanding Hasura. Quick disclaimer, Hasura now has a cloud offering. When we were starting this, and right now, we're using the open source version of it. So first off, one of the things we've always liked about Hasura is their documentation is good and easy to follow. Most of this information you can find just on their website. But Hasura generates a instant GraphQL service on top of an existing Postgres database. They also support other databases, but for our application, Postgres was what we cared about. They provide a built-in way to manage migrations. They also have some more advanced features, like an ability to trigger webhooks based on database events. For example, if you insert into a certain table, you can call back and do something with that data, whether it's call to an external service or store it in a different way, whatever, it works well. They also allow you to merge in some hand-rolled GraphQL or REST APIs with their service, allowing you one place for your front end to talk to. Some initial points for us that made it seem like a good fit were the fact that we got to keep Postgres. This is their ability to run easily locally without requiring any online interaction. That's always been an important part of our development cycle, is running something as close to production as possible while also limiting how much we actually need to call out. The operation story was pretty simple. We use ECS, or Elastic Container Service. So this was just another container we were able to plug in. Because we kept it, we didn't need to do a complete overhaul of the front end, and it cleared up some space for us to do some polish. It also just kind of worked, which it's always magical when you find a piece of software that works like you expect it to. After spending some time with it, we have some more things that we like now. First off, we still like everything we originally liked, which is good that none of those things have changed over time. Now we're using some of the more advanced features like event triggers. Event triggers in particular have saved us a lot of operating costs and money because we can handle incremental changes to certain data that's flowing in. Because we get a payload with here's the original thing, here's the updated thing, we can check if any of the fields that we care about change. And if they do change, we can make that call. If not, we don't have to make that call. Using remote schemas allowed us to have specific endpoints with a little added security or rate limiting on them, while still having a simple place for our front end to talk to. There's also some added security with having a very strict allow list on in deployed environments. Because Hasura exists and doesn't require us to actively be hosting the GraphQL service ourselves, we can parallelize work on the back end and front end and work on front end polishing or requesting new fields without the back end team needing to come in and do anything. It's also very surprisingly performant. Its speed and ability to handle a heavier load has been proven time and again. Part of that is how they take GraphQL queries and put them into a single prepared SQL statement. Even though we came to GraphQL mostly through Hasura, GraphQL still makes sense for this problem. Some of the reasons for that are things like subscriptions, which you don't really find something equivalent in simple REST APIs. How we use it is for a given pretty large booking item, we're waiting on a confirmation for or a cancellation for that given booking item. It saves us on processing costs because we only need to care about that one change. And creating that experience for a user would have been hard without using GraphQL and subscriptions. GraphQL allows you to ask for exactly what you want. Because queries are explicit about the data that they're requesting, it's easier to maintain types in the front end without having to maintain a type system for disparate code bases. It also, graph is literally in the name. It allows you to return the object graph. So instead of needing to make multiple calls to get suppliers and then all the locations for the suppliers and all of the items for given location, you can ask for all of that in one blob, saving some of the back-end calls. We also discovered that there is a lot of existing tools and support around GraphQL, even for our language of choice, Clojure. This isn't a Clojure talk, so I won't go too deep into Listenia, but in order to implement a couple of our remote schema endpoints, we used Listenia, which was built by Walmart Labs, and it's a Clojure implementation of the GraphQL spec. Some things I wish I could go tell ourselves, our past selves, is there were really three main ones. One, we initially conflated the idea of Hasura and GraphQL. I think shared vocabulary when working on any complicated project is important. It decreases cognitive load. It lets you have better communication both internally with your teammates and externally with the stakeholders. And it also really helps with Googling, which is important when working with new technology. What we now know is Hasura enables you to use GraphQL by generating those endpoints for you. But GraphQL at the end of the day is just the query language. Another mistake we made, which isn't inherently wrong, but was a carryover from the original build, was having our backend also be talking directly to Hasura instead of talking to Postgres. Again, there's nothing inherently wrong with that, but for us, it created an unnecessary dependency between Hasura and our new transformation service. And Hasura is built to handle data changing beneath it. The thing that we've probably struggled with the most and still struggle with a little bit today is actually checking that things are working with Hasura. Currently, our applications mostly use a combination of CloudWatch, New Relic, Datadog, PagerDuty to get some visualization into, are things working? Are we getting any errors? Can we track those errors through the system? At the time when we were originally building this, it wasn't straightforward for how to link Hasura into that infrastructure. There was some articles about Datadog and Honeycomb, but most of those were using Kubernetes. So we found some imperfect workarounds, namely we upped some security in prod and other deployed environments, making the query list very strict. We increased low-level database monitoring, and we upped our error handling and observability around Hasura. This has improved in newer versions of Hasura and has especially improved in their cloud offering. I'm pretty sure it's just baked in now. So what we've learned so far, I think at the end of the day, my team has come to the conclusion that GraphQL is here to stay. We had a really great experience with building this out, and we're surprised at how approachable it actually was at the end of the day. The GraphQL is a huge ecosystem full of supportive tooling. There's Hasura itself enabled us to quickly level up with it and implement it into our project. Our time saved from embracing GraphQL helped us meet our deadline, which made both our team and our customers really happy. We will likely use GraphQL for future projects, which is exciting. I think both myself and my team are really excited to be part of this community going forward. So with that, I'll finish off. Thank you so much for tuning in. I hope everyone is staying healthy and safe during these pandemic-y times.
Excellent talk, Brooke. Again, my gray matter is working extensively. And while listening to your talk, one of the first things that popped into my head was, whoa, you're using Clojure. I've rarely seen shops using Clojure, and I'm very curious, how have you found using GraphQL and with Clojure and using I believe the library was called Lucinia, something like that? Yeah,
it's called Lucinia. It's developed by Walmart Labs. It's like pretty straightforward. It's a little different in the server that it uses is called Pedestal, which I think people tend towards using a ring server in Clojure land, at least in my experience. So that was a little bit different in that we had to get used to like both a different server and like implementing the GraphQL spec and what that meant. I think we weren't fully aware of all of the GraphQL things before we actually started building it out. Now with a little more experience, it's been easier to go back in and like tweak some things. But in general, the library support was really solid. The documentation was there. And I would say that Clojure is like a more niche language. So the fact that we were able to find like so much support even in Clojure was really great.
Yeah, one of the great things about GraphQL is the support kind of goes out to the far reaches of even the most niche language these days. So it's covering the gamut. One of the things with that library and the pedestal server, you mentioned ring servers and all that. So like that tooling is used to build up the servers. Is that tooling the Licinia? I feel like I keep saying it wrong, but is it used to make the client calls also? Like if you're calling to Hasura, you're using that for that too. Is that correct?
So we on the back end are no. Licinia lets you like actually build the service, the like actual GraphQL endpoints. So
right.
We from the back end are not calling the Hasura generated endpoints. Hasura just like will replay traffic to our remote schema. It just
I got you.
Like makes those endpoints exist basically. And conform to the GraphQL spec.
Nice. Very interesting. I have to check that out some more. Clojure has always been one of those fascinating languages that keeps cropping up for me. I'll have to see how it compares to my Haskell, my very new Haskell experience. So,
there are far less types.
Yeah, this I've heard. So, one other question that I had was, overall, as you inherited this project and the various pieces, and you might have spoken specifically to this, but I'm just curious, like if you had to pick one thing that really made you decide, okay, we're going to keep Hasura in the loop for our GraphQL, what was the thing that really stood out the most in deciding to stay with Hasura?
I think probably ease of operation tied with documentation. Being able to actually read through everything and have a pretty good understanding of how things were supposed to be working with it was huge. Leveling up on any new technology, the better the documentation, the easier time you're going to have. And we've had a really good luck with the Hasura docs. But also just the fact that it's Dockerized and can just like kind of plug into anything, and worked really well just with Postgres, is made it a win for us.
Excellent. That sounds like a good top reason. Thank you so much for this talk, Brooke. Loved hearing about your experience. Have a great conference. Appreciate it.
Thank you.